All right, so here we are in the course GitHub repository that you're already familiar with. And I'm going to take you down to the starting point code. So this is the code that you'll use to get started with the RISC-V labs exercises. And I'm going to control click on this link to open it in its own tab. And I just want to quickly walk through the code that we're providing for you. Really the only thing that you need to know here is where to write your code for the lab exercises. That's here. But it's nice to have a little context on what you're given. So just to walk through what's here, this is structured like any TLVerilog file inside MakerChip. It starts off with a version line that specifies the TLVerilog language version of the file. This is 1D, and it specifies that we want to use a macro preprocessor called M4. So M4 is processing macros such as this one. This one is grabbing some library content. It's actually grabbing some macro definitions that we're going to use elsewhere. So we grab some of the content that we're providing. That's providing you with the visualization capabilities. It's providing you with some macros that you'll instantiate for the register file that are down here at the bottom, for the register file and the data memory. So these are macro instantiations. And this is the macro instantiation of the visualization. So these two lines up here are grabbing those definitions. Next is the program that is going to exist in your instruction memory that you're going to be executing in simulation. And this is what you saw in the previous video. So same program, summing numbers from actually 1 to 9, not 1 to 10. And let's see. So basically through macro preprocessing, we're turning these human readable instructions into binary that your CPU core is processing. Then we have the module definition that the MakerChip platform expects to see. So this again is a M4 macro instantiation, which looking in the nav TLV, we can see the expansion of that macro. So we're seeing that that expands to a module definition that's expected by the MakerChip platform, and the MakerChip platform provides through that interface the clock and the reset that control your logic. It's also giving you a cycle count, and you are able to pass back to the platform a passed and or a failed signal. And we're doing so here. So here we're telling the platform we're never going to report passed, and we're just going to report fail always after a fixed number of cycles. And that number of cycles is defined up here to be 50. So after 50 cycles, we're always going to report failure. And as your core gets sufficiently capable, we will add some logic here to define the pass condition and the fail condition. But for most of your coding, you're not going to rely on what's reported in the log. We can see in the log here that we're reporting failure. We're not going to rely on that. Your logic is very dynamic, and you'll just use the visualization to understand that each piece of logic that you add is properly reflected in the behavior that you're able to visualize. All right, so that's where you start, and in the next video I'll introduce you to some reference solutions that we're also making available to you to help you if you get stuck.